Hello student, welcome to ROSE project. ROSE means Rayat Online School Education. These ROSE projects are conducted by Rayat Shikshan Samstha Satara and as well as Sadguru Gadge Maharaj College, Karad. I am Ms. Zadav PS. My subject name is Chemistry and today we see a new topic. The topic name is Green Chemistry and Nanochemistry. So we'll so we first introductions. And before the introductions, this green chemistry and the nanochemistry, these units, they having the 3 marks in a board exam, or the weightage of a this green chemistry and the nanochemistry is a 3 marks with without option, and with with option they having the 4 marks. Then introduction of a green chemistry. Nowadays the problem is like increases in population, increases in population, industrial revolution, energy crisis, and all above major global problems. The solution of a green chemistry is the solution of a these problems is green chemistry. So we'll see a definition of a green chemistry. The green chemistry is the use of chemistry for the pollution prevention by environmentally conscious design of chemical products and the process that reduce or eliminate the use or generation of a hazardous substances. Then approaches of a green chemistry. First is maximum efficiency and the second is minimum hazardous effect on human health and the environments. Then next, the concept of a green chemistry is coined by Paul T. Anastas. The concept of a green chemistry is discovered by the Paul T. Anastas. Then next, the sustainable development. The sustainable development means the development that meets the need of present without compromising the ability of a future generation to meet their own needs. It means that the need of a present generation and the need of a future generations, these are completed by the sustainable development without any adjustment or without any compromising. Then next point is a principle of a green chemistry. The principle of a green chemistry is a 12. First principle of a green chemistry is the prevention of a waste or bioproducts. First, to give the priority for the prevention of a waste rather than cleaning up and treating waste after it has been created. First, illustration. To develop the zero waste technology, ZWT. The second, in terms of a ZWT, in a chemical synthesis, the waste product should be zero or minimum. Example. First, bottom ash of a thermal power station, they can be used as raw material for cement and brick industries. In a thermal power station, the electricity is produced. The thermal power station has the thermal power plant, and the thermal power plant, the chemical reaction is carried out, and as the byproduct is a bottom ash, and this bottom ash is a waste, and these are used as a raw material for cement and brick industries. Then second, the influence coming out from cleansing of a machinery parts may be used as coolant water in a thermal power station. Then next, atom economy. First, the atom economy is the measure of a amount of a atoms from the starting material that are the present in the useful products at the end of chemical processes. Then second, The good atom economy means most of the atoms of the reactant are incorporated in the desired products and only small amounts of unwanted byproducts are formed, and hence the lesser problems of waste disposal. Then next, the percentage of a atom economy is equal to the formula of a weight of the desired products divided by the sum of formula of weight of the all the reactants used in reaction into 1000. For example, the conversion of a butane 1-ol to the 1-bromobutane CH3 CH2 CH2 CH2OH, that is butane 1-ol plus NaBr plus H2SO4 gives to the CH3 CH2 CH2 CH2Br. It means 1-bromobutane plus NaHSO4 plus H2O. The percentage atom economy is equal to the mass of butane 1-ol 4 carbon plus 9 hydrogen plus 1 Br. The mass of a butane 1-ol is 137 U divided by mass of a 1-bromobutane 4 carbon 12 hydrogen plus 5 O plus 1 Br plus 1 Na plus 1 S. The mass of a 1-bromobutane is a 275 U into 100. Then division of a 137 to 275 is equal to the 449.81. The percentage of a atom economy is equal to 49.81%. Then illustration. The concept of atom economy gives the measure of the unwanted products produced in a particular reaction. Then next, third principle of a green chemistry is less hazardous chemical synthesis. Less hazardous chemical synthesis. The designed chemical reaction and synthesis route should be as safe as possible so that we can avoid the formation of a hazardous waste from the chemical process. We use the less hazardous chemical synthesis in a chemical reaction. Illustration. Earlier, DDT, that means dichloro-diphenyl trichloroethane, was used as insecticide and which was effective in controlling the disease like typhoid and malaria carrying mosquitoes. Mosquitoes causes the typhoid and malaria disease. These are controlling by DDT as a used as insecticides. Then it was realized that DDT is harmful to living things. Nowadays, benzene hexachloride BHC is used as insecticides. One of the gamma isomer, that is gamma of BHC, is called as gammaxane or the lindan. Okay, and this BHC, that is the benzene hexachloride, it is not harmful to living things. Then next, fourth principle of a green chemistry is the designing safer chemicals. Then this principle is quite similar to the previous one. To develop the products that are less toxic or which require the less toxic raw material. We design the safer chemicals. These are the less toxic as a raw material. These are the less toxic raw materials. Illustration. In a chemical industries, workers are exposed to toxic environments. In order to prevent the workers from exposure to the toxicity, we should think of designing safer chemicals. Example, adipic acid. Adipic acid is widely used in polymer industries. Benzene is the starting material for the synthesis of adipic acid. But Benzene is a carcinogenic. Carcinogenic means they can causes the cancer. It is called as carcinogenic, and the benzene being volatile organic compound VOC, they pollutes the air. The vapors of a benzene, they these are very harmful to the human beings. Nowadays, the adipic acid is a synthesizer from the glucose, and the glucose these are not very harmful to the human beings. So next, the fifth principle of a green chemistry, use the safer solvent and the auxiliaries. Choose the safer solvent available for any given step of reaction. They minimize the total amount of solvent and auxiliary substances used, as these make up large percentage of a total waste created. So we use the safer solvent and auxiliaries in a chemical reactions. Illustration. The main aim behind this principle is to use the green solvents. Example, water and the supercritical CO2 in place of volatile halogenated organic solvent. For example, CH2Cl2 dichloromethane CHCl3, it means chloroform CCl4 carbon tetrachloride for the chemical synthesis and other purposes. The solvent as chemical that dissolve the solute and form the solutions. They facilitate many reactions. Water is a safe benign solvent, while dichloromethane is hazardous. In nowadays, water and the supercritical CO2 solvent most of the use in place of a volatile halogenated organic solvent, or in the place of a chloromethane, chloroform and the carbon tetrachloride. So next, sixth principle of a green chemistry is design for energy efficiency. In chemical synthesis should be designed to minimize the use of energy. It is better to minimize the energy by carrying out the reaction at room temperature and pressure. These can be achieved by use of proper catalyst, use of microorganism for the organic synthesis, and use of renewable materials, etc. The design in a principle of a design for energy efficiency, we use minimum energy for these reactions and also use the proper catalyst, use of microorganisms, or use of a renewable materials for these chemical reactions. Okay, then illustrations. The biocatalyst can work at the ambient conditions. Similarly, in a chemical synthesis, refluxing the condition require the less energy. Improving the technology of heating system, use the microwave heating, etc. Then next, principle of a green chemistry, the seventh number of a the seventh the seventh number principle of a green chemistry is use of renewable food feedstocks. The perspective of this principle is largely toward petrochemicals. Use the chemicals which are made from the renewable, that is a plant-based sources rather than other. For example, crude oil. We in a chemical reaction, we most of the use the renewable sources feedstock. Then illustration. The use of a renewable resources, for example, agriculture or biological products, ensure the sharing of resources by future generation. This practice generally does not put much burden on environments. The products and the waste are generally biodegradable. Then next, 8th number principle of a green chemistry, reduces the derivatives. It means the minimization of a step. We also know the chemical reaction. We also know the some chemical reaction they carried out in a number of steps, and these number of steps, these are the minimized. A commonly used technique in a organic synthesis is the use of protecting or blocking the groups. Unnecessary derivatizations, for example, installation, removal of a use of protecting groups should be minimized or avoided if possible, because such steps require additional reagent and can generate the waste. In organic synthesis, we need a very often protection of some functional groups. Finally, we again need their deprotection. Example, synthesis of a meta-hydroxybenzoic acid from a meta-hydroxybenzaldehydes. In a reactions, first the meta-hydroxybenzaldehydes then converted into these products. In this reaction, the protection of a OH groups carried out. The oxidation of these products to form a new products, and these new products are converted the meta-hydroxybenzoic acid. In this reaction, the deprotection of a OH group is carried out. Okay. The next principle of a green chemistry is use of catalysis. You also know the use of a catalyst in a chemical reaction speed up its rate, and the catalyst helps to increase the selectivity, minimize the waste, and reduce the reaction times and energy demands. You also know the use of a catalyst in a chemical reaction, they speed up its rate. In a next lecture, we see a next point. So, thank you.